This is an interesting question. We have a calorimeter which contains 50 grams of water at 50 degrees Celsius. The temperature of the system falls to 45 degrees Celsius in 10 minutes. Now when the same calorimeter contains 100 grams of water at 50 degrees Celsius, it takes 18 minutes for the temperature of the system to fall to 45 degrees Celsius, and we need to find out the water equivalent of the calorimeter. Now whenever there is temperature change and time involved, we think of Newton's law of cooling. Therefore by Newton's law of cooling we know that delta T upon time taken is equal to minus Ka into T of object minus T of surrounding. Now this T of object, since it is not constant, we can take this to be the average value. Now delta T is same for both the cases. The time is different. So let us write the equation for the first part. Delta T upon 10 minutes is equal to minus of K into A. This the A is the surface area of the object of the system that remains to be the same, into average of T object minus T of surrounding, let that be T naught. Now an important thing which you should keep in mind for this question is, let me write the second part first. For the second part, there is same change in temperature delta T, so the rate of decrease of temperature can be written to be equal to delta T upon 18. This is equal to minus of K dash into A into the same T object minus T naught. This remains the same. The only change occurs in, there is a K dash over here. So for this you should remember, at least you should know what are the terms or factors or quantities that come in the making of this K. So that is very important. We should know that this K is equal to, when brought down from the Stephen's law, so from sigma EA T raised by 4, the formula for the heat the rate at which the heat is radiated from the object, that is sigma EA T raised by 4, from that it can be derived. But you should remember that the value of K is equal to 4 E into sigma into T naught cube upon ms, whereas is the specific heat of the object, m is the mass of the object, and sigma T naught is the temperature of the surrounding. Now the only thing which is of our concern is m into s. We need to find out the water equivalent of the calorimeter. Let that be equal to m. Now when the water equivalent of the calorimeter is m, it can be directly added to the mass of water and normal calculations can be done. Therefore in the writing of this, here we write delta T upon 10 is equal to minus of some constant, let it be K double dash, upon mass of water, that is 50, plus the water equivalent of the calorimeter. The specific heat remains the same, into T object minus T naught. On the right hand side we will write delta T upon 18 is equal to minus of the same K double dash upon 100 plus, this is m, sorry, 50 plus m, 100 plus m. Since the mass of water is increased, therefore the total mass which will come over here will increase into s. This s was already taken care of in K double dash, let us include it in K double dash itself. So this comes out to be this into T object minus T naught. Now dividing these two equations we get 18 upon 10 is equal to 100 plus m upon 50 plus m. That is 9 upon 5 is equal to 100 plus m upon 50 plus m. 450 plus 9m is equal to 500 plus 5m. 4m is equal to 50. M is equal to 12.5 grams. So final answer for the water equivalent of calorimeter comes out to be equal to 12.5 grams. The important thing which you should remember in this question, from this question, and rather learn from this question, is that what is K composed of in the Newton's law of cooling. At least you should remember this, that there is a factor of mass coming down in the denominator in the formula for K. Therefore the final answer that we get using this formula for K comes out to be equal to 12.5 grams.